Okay guys, going to take a quick look here at the 2019 CAMS question there. So what you're looking for, I'll just video that for a second, is the rise is 90, which is big enough. And you don't need to draw the cam. And they asked to use 15 millimeters for every interval, which is unusual enough. But anyway, it doesn't make a difference. So the rise and fall is 90 millimeters. That's the key thing we want there, and spacing of 15. So I'm just going to mark up here a height of 90. So I want to just keep it up fairly close to the top there. So there's a height of 90. Don't need to write it, but I just will there to help you. So I'm going to draw a box. Now normally I would use 10s for intervals, but we were asked to use 12 distances of 15s here. So I'm just going to start marking 15s. So that's my 12 intervals. Now make sure you've got 12 spaces, not 12 dots, big difference. Okay, so we want 12 spaces. And I'll just put on these verticals here. I'll just draw them a little bit heavier than I normally would, so that they will come out on our video here. So now this is our follower displacement diagram, so just double checking. Okay, so just go from 0, 30, 60, 90. So there's all our distances as it turns. Now we're not asked to draw the cam here, so I'm not too concerned. If I was asked to draw the cam, I'd be keeping it further to the right, but we're just asked to draw the follower displacement diagram. So I'll just write down the movements up here as well. So from 0 to 60 degrees, it's rises 90. Uniform velocity. Okay. Then it dwells 60 to 90 dwell. So the 60 to 90, we know that's at the full height there, so I can actually heavy that in straight away. Then 90 to 270, it falls 60. Okay, so from 90 to 270, it falls 60. So I'm going to just mark down that 60 here. And that's with uniformed acceleration retardation. And finally there then 270 to 360, it returns to the original position with uniform velocity. Okay, now uniform velocity is great news for everybody, because that is a straight line, and since it rises from 0 to 60 degrees with uniform velocity. So that's good news as well. So really the only place there's any brain work involved is between whatever's happening is happening basically in this rectangle here, and that is 90 to 270, where it falls 60 with uniformed acceleration and retardation. Now, the uniformed acceleration and retardation is basically like two parabolas, but I'm just counting my spacing here now, 1, 2, 3 and 1, 2, 3, which is perfect. So really I want to divide this height here into 6 equal distances. Now if it was an uneven distance, I would have to use the construction there of division of a line, but because that's 60 I can just go with tens, which makes this very, very handy altogether. So this is going to be like the right hand side of a parabola. So just joining them back up there, and so over 1/3, so I've got 3 equal distances here, 3 equal distances here. So it's going to there, going to here, and going to there. So that is going to be my first half of it. Now normally I would just do the other side as well, but that is like the right hand side of a parabola. And then the other side here, we've just got an upside down half a parabola. So first one, second one, third one. And that is that. So uniform velocity is a straight line. There's the dwell. There's the falling by uniformed acceleration and retardation, and it falls the rest of the ways with uniform velocity. Now guys, just a quick look there at the second part of this here. So you've got a wheel rolling along the line. Scale is 1 to 10, so it's radius 35, and it's up there 22 on that spoke, and you're to plot the path of the reflector for 1 full revolution clockwise. Okay. Okay, so just to condense the space here, I'm going to keep this, I'm going to just put it on the margin, because it'll keep it right down the bottom. So I want 35 is the center of the circle. So here's our circle. Just divide it up with the 30/60. There's our spokes. Now you've got two choices doing these type of questions. You can use heights or you can use angles. Now I'm going to use angles on this one. I just think I prefer it. Now the next thing I want to do there is I'm going to just put the height of that reflector is up 22. On that spoke. Now what I'm going to do there is I'm going to colour this spoke in as green. Okay, so that spoke there is green, and this is our reflector on it. Now basically what happens here is every time the wheel rolls 1/12, the center moves this far to the right. So I'm going to step my 12 positions for the center over here. Now every time then that the center moves at 12th, the spoke will move clockwise by a 30-degree angle. So when it goes to here, that spoke is going to be 35 horizontal. Then when it goes to the next one, it's going to be 35 going at a 30-degree angle here. Now the next one, it'll be 60-degree angle. Then it will go vertical. Then 60 degrees forward, 30 degrees forward, horizontal from here. So I'm going to draw those in just so you can keep a track of this. So every one of these is 35. Now I don't need the spoke in all of these, but I just think it'll help people to understand what the hell is going on. So and the reason I say I don't need the full spoke is because the reflector isn't all the ways out to the end. Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8 positions done. So now it's sloping down at 30, down at 60. Here it's going to be gone vertical, and then 60 degrees this way, and back to where we started. Okay, so there are all the spoke angles. Now the one place that it is easy enough to get confused, just sharpen the old pencil there, is back here. There's a lot going on here. So 35, so 35, down at 60, the 35 vertical is going to be just straight down here, then 35 back this way, and finally we're finishing with 35 in this angle. So that's where we started, and the next move then is I would just be measuring how far from the center is that red reflector there. So it's that far on every time it changes. So on the first one, it's here. Now I'll go a bit slow and I'll just draw it in every time so people can see what I'm doing. So that's the position of the reflector on that spoke. as we roll along. And that there is all the points we need for the locus. So I wouldn't go drawing this in an exam. I wouldn't go drawing this in one go with a red biro under any circumstances, but and that there is the locus of that as it rolls along one full revolution. So I hope you enjoy that.